Hello everyone, in this video I will teach you how to find the length of a linked list or count the number of nodes present in the linked list. Now see, there are two ways to find the length of linked list. One is iterative process and other is recursive process. First I will teach you the iterative process. See, now this is the given linked list of 4 nodes. This is first node, second node, third node, fourth node. Now you should count number of nodes present in the linked list. There are 4, so you should return 4. How you will find? Let's see. This pointer part I am storing the address of next node. Address here is 200, so 200 is stored here. Address is 500, so 500 is stored here. Then here 600, so 600 is stored. Now here 0 because no node is present after this. Now head pointer stores the address of first node. Address of first node is 100, so 100 is stored here. Now see, now you should count the number of node present in the linked list. So first step is you should take a pointer, take a variable count. This is a variable count. At starting you should put default value count as 0. This count variable is used to store the number of nodes present in the linked list. Now see, I have put the value 0 at starting. Now second step is you should create a pointer called temp. Now this temp pointer should point towards the first node. How it will point? If you write temp equals to head, because head is used to point the first node. So if you write temp equals to head is 100. So if you write temp equals to 100, then it points towards the address of first node. It points first node. Now see, this is the second step. Now when the linked list is not empty, now it's not empty, so it's pointing towards a node. Some node is there. So at starting, now it's pointing towards the first node. Now you should increase the first step is you should increase the count value by 1. So now it was 0, so it incremented by 1. Now the second step is you should move the temp pointer pointing towards the second node. So how you can point it towards the second node? You should change the temp value. Temp equals to temp next. Temp is 100. 100's next is 200. So the value changes to 200. If you change to 200, the pointer points towards the second node. Now see, now the same step is followed. What step was previously done in first node, the same step is followed. That is increment the count value by 1. Now the pointer is pointing towards the second node. Now increment 1 value to the count variable. Now it's 1. So increase 1. Now it becomes 2. Now the second step is you should move the temp pointer towards the next node. So temp equals to temp next. 200's next is 500. So I'll change the value to 500. Update the value. Now this pointer points towards the third node. Now again the same step is followed. That is count values increased by 1. Now it's in third node. Now count values increased by 1. It becomes 2 plus 1, that is 3. Now see, now you have incremented count value. Now you should move the temp pointer pointing towards the next node. So temp equals to temp next. 500 next is 600. So the value changes to 600. Then the pointer points towards the 600, means it's point towards address 600. Now see, now the same step, increment count value by 1. So it becomes 4. Now this was 600, right? Temp equals to temp next. So 600 next is 0. So update this temp. So 0 it becomes. Now it is pointing towards the next node. No node is present after this. So the temp value is 0. So you should now you should stop it. Now you can say you should return the count value. Count is now 4. So you can say length of linked list is 4. So you should move the temp pointer. You should move 1 by 1 till temp is not equals to 0. Now temp is equals to 0, right? So you should stop. This is the process. Now I'll teach you how to write the code. See here. Now first one, I'm writing the function int get count struct node pointer head. Now what is this? This is the get count function. This is the function count, which is used to count the number of nodes present in the linked list. Now this is pointer head. This is head pointer, which is pointing towards the first node. Head pointer is pointing to a node. That's why I am writing struct node. Now see, Now at starting I had created a variable count which was 0. So I am writing here, see, int count equals to 0. I have set the count variable 0 at starting. Now the first step is you should create a temp pointer. First step is you should create a temp pointer which is pointing towards the first node, and the temp pointer is pointing towards the first node. So temp is 100, right? So I am writing that, see, pointer temp. This is the symbol. This is the symbol used to represent pointer. If you don't write this, it's not considered as the pointer. So see, this is temp pointer which is pointing towards the node structure. This is a node. So I am writing struct node. This temp pointer is value is what? It is value of head. It's 100. So this is equals to head, because head is used to point towards the first node. So I am writing temp equals to head. Now see, now the first step is when the temp is pointing towards the first node. At starting count was 0. You have incremented count value to by 1. So 0 will become 1. So what you did, count plus plus. You are increasing count value by 1. So this is the first step. So I am writing count plus plus. This is same as count equals to count plus 1. Now see, now next step is, first step is you have incremented count value. Next is you should move the pointer pointing towards next node. How you can write? Temp equals to temp next. Temp is 100. 100's next is 200. So it's pointing towards 200. I'll update this value to 200. So I'm writing that temp equals to temp next. Now this is the 2 step. Now see, now again you should go back and do the same step. You should increment the count value by 1. Now count value was 1. So at this step you should increase the count value by 1. So it becomes 2. Then temp will become, you should move the temp pointer pointing towards the next node. Like this. How you can make temp equals to temp next. Same step it comes. So 200's next is 500. So 500 it comes. Like this. Then again you should follow the same step. Now count is 2. You should update the count value, increased by 1. So it becomes 3. Then temp equals to temp next. It's pointing here. So this is 600. Till how much you should move the temp value? This is a loop. So till how much you should move the pointer temp? You should move till, now see, now at this step temp is 600, right? Now again you have incremented count value. Count is 3. Now when this temp is pointing at 600, count value increases by 1. So it becomes 4. Then this step temp equals to temp next. So 600's next is 0. So temp is 0. Now this is pointing towards the next node, that is no node is present after this. So at this step you should stop, because you should not do the same step. You should not increase the count value again. 4 plus 1, 5 you should not do. So you should stop at this step. When you should stop? When temp values equals to 0. So you should do this step till temp is not equals to 0. So I am writing this condition, while temp not equals to 0. So now temp is 0. So it does not enter into this condition. It does not increase count value by 1. It stops. So this is the step. Now you should return the count. Now count is 4. You should return it. So I am writing return count. This is how you should write the code for iterative process. Now see, now I will teach you how to write the code for recursive function to count the number of nodes present in the linked list. First I will write the code, then I will explain you. See now. Now I am writing the same function, get count function. So see here, int get count struct node pointer head. Now this is the count function which is used to count the number of nodes. Then this inside this parameter is head pointer. This is the head pointer which is pointing towards a node that has a structure. Now that's why I am writing this pointer head. Now see. Now first condition I am writing base condition, that is see. If head equals to null, then return 0. What is this? See, in recursive function, you will write the base condition. Base condition means recursive means it goes into again and again, it goes into loop. It should have termination point. That is this base condition. This is the terminating point. If head is 0 means return 0. What is that? See, now this is the condition to check whether the linked list is empty or not. Now there are 4 nodes. Now if suppose no node is present in the linked list, then suppose these nodes are not present, then head value will be 0. Head value is 0 means it's not, this pointer is not pointing to any node. This no nodes are present. Then if head is 0 means if the linked list is empty means the count value will be 0. That's why I'm writing return 0. That is this condition. Now this is not empty. Now 100 is there. 100 means it's pointing towards the first node. So I'm doing the other condition, else condition. See, else return 1 plus get count. This I am calling the recursive function, the same function, get count of, but here head is the head pointer. Now I'll write other pointer. See here, struct node. Now pointer is head next, not head. What is this? I'll explain you by tracing the code. Now see, now I'll explain this line by tracing the code. Now see, now I'm going into this function. Now get count function is called. Now I'm checking first condition is if head is null or not. I'm checking. Now see, head is not 0, head is 100. So I'm not returning 0. I'm going to else condition. Now see, now return 1 plus get count. See, now I'll trace the code. 1 plus count function. Count function of what? Head next. Pointer is head next. Now head is what? Head is 100. So hundreds, this is 100. 100 next is 200. So now 200 will be the value here. So I'm writing count 200 is called. Now see, now 200 means it goes into this function, get count function. Now this function is called. Now head pointer is 200 now. It takes the parameter 200 as head. Now see, head is 200 means this value changes to 200. Now this pointer is pointing towards the second node because 200 means it's pointing to address 200. Now see, now it's checking again. If head is 0, head is not 0. So it goes to else part. Now I'm calling the function 1 plus get count of struct node head. So this recursive function is called 1 plus count of. Now see, head next. Head is 200. 200's next is 500. So count of 500. This function is called. Now see. Now 500 is, it's calling back the same function. Now head is 500. So see here, head value is 500. Now 500 means this pointer is pointing to the third node. Now see. Now I am again calling this function. Now it's checking. See. Now this count 500. Now I am checking this. If head is 0, head is not 0. So I am going to else condition. Now else return 1 plus, see 1 plus this again recursive function. So 1 plus count of head next. Head is 500. 500's next is 600. So I am putting here 600. Count of 600. Now this function is called 600 is head now. So I am changing the head value to 600. Now 600 means this pointer is head pointer is pointing towards the node which have address 600. Now see, now I am again checking if head is 0 or not. Head is not 0. So I am going to else condition. Return 1 plus count function. So I am see 1 plus count of head next. Now head is 600. 600's next is 0. So I am writing count of 0. Now see. Now again the function is called recursive function. Now it's checking whether head is 0 or not. Now see. Now this head parameter is 0 now. So I am writing is 0. Now it's checking if head is 0. Yeah, it's 0. So now return 0. So now see. Now this value is 0. So now the recursive function is called. Now you should trace back. Again you should go back and count. See. Now you are going back. Now here 1 is there. So 1. Now again you are going back. Then here 1 is there. So 1 plus 1, 2. then again going back, then here plus 1, so plus 1 3, then again you are going back, here plus 1, so 2 plus 1 is 4, so count as 4 now. So see, 4 nodes are present. So this is how you will write the code for recursive function. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.